This is a rational inequality. We have a rational expression 2 divided by x minus 6 less than another rational expression 1 divided by x minus 4. This is a step further than nonlinear inequality. So first of all, just like solving a nonlinear inequality, I would like to move all the fractions to one side. So that is 2 divided by x minus 6 minus 1 over x plus 4 less than 0. And then let's get a common denominator. So the common denominator is x minus 6 times x plus 4, and then this is a 2 times x plus 4 minus 1 times x minus 6 less than 0. And then you have 2x plus 8 minus x plus 6. So that is x plus 6 plus 8 is 14. So you have x plus 14 on top, and then that will be your function. Okay, so this is a 2x plus 8 minus x plus 6, right? So that is equals to x plus 14. So therefore, the top is x plus 14, and then the bottom, keep that in a factor form. X minus 6 times x plus 4 less than 0. And then what is my function? I am going to claim everything on the left hand side to be my function. So my function is f of x equals to x plus 14 divided by x minus 6 times x plus 4 equals to, I would just not write equal. I would just leave it in there. Now, finding the key numbers. In nonlinear inequality, I set everything, I set the entire function equals to 0 and solve for x. So for a rational function, you have to take care of the numerator and denominator. So to find the key numbers, you know what? Let me just use a different colors to do it. You have to take care of the top and bottom, every single factor. So the top, x plus 14 equals to 0, and then the bottom, x minus 6 equals to 0, and x minus 4 equals to 0. You have to take care every single factor. This is x equals to negative 14, x equals to 6, and x equals to 4. So these are the key numbers. So you have 3 key numbers. And then you put them on a number line. 3 key numbers. So you draw a long number line, and then you have your negative 14 and your negative 4 and your positive 6. We have one line, 3 numbers that divide the line into 4 intervals. The first test interval is from negative infinity to negative 14, and then from negative 14 to negative 4, and then from negative 4 to positive 6, and then from 6 to positive infinity. You have 4 intervals. Let's drop them down. So negative infinity to negative 14, negative 14 to negative 4, and then from negative 4 to positive 6, and then from positive 6 to positive infinity. And then within each interval, you pick a test value. So for the test value, pick something easy, negative 15. This one, I will just pick a negative 5. This, my favorite, 0. And then this is 7. And then at the very beginning, we have this piece less than or equal to 0, and then you claim that to be your function. You have to plug in each test value to the function to see which one is less than 0. So this is one of the ways to do it. Another way to do it is you plug in each test value to the original inequality to see which one is satisfied. Again, 2 ways to do it. You have this big fraction less than 0, and you claim that to be your fraction. You plug in each individual test value to the function to see which one is less than 0, because this is less than 0. The second way to do it is you plug in each test value to the given inequality to see which one is satisfied. You have 4. You have to tell me which one is satisfied. So I will just stick with the function. So let's do the plug-in. So we have f of negative 15. So that is equals to negative 15 plus 14 divided by negative 15 minus 6, and then negative 15 plus 4 this is equals to -1 divided by 231, and then you have your f of 5, so that is 5 plus 14, and then 5 minus 6, and then 5 plus 4. If you are lazy about calculating what that equals to exactly, just tell me whether that is positive or negative. This one, I see that there is a negative in here, so the whole fraction is negative. Oh, -5, huh? I was doing this too fast. Okay, my mistakes. So this is a -5, and then the bottom I have to fix it. Okay. -5. Okay, -5 minus 6. Okay, so now we have a positive, a negative, and then this one is -5 plus 4. So we have two negatives in the denominator and then a positive on top. So at the end, this will be a positive. But if you do the math, that is 9/11. 0 should be easy. 0 plus 14, that is positive. 0 minus 6 negative, 0 plus 4 positive, so this is still negative. That is a negative 14 divided by 24. And then the last one, f of 7, so that is a 7 plus 14 divided by 7 minus 6, everything is positive so far, and then 7 plus 4, so positive. This is 21/11. Now, we are looking for less than 0, right? Which one is less than 0? Simple. This is less than 0. This is less than 0. So we are taking these two intervals to the solution set. So the solution set at the end of all the works, we have two solution sets that is from -infinity to -14, and then from -4 to +6. There is no less than or equal to, so there is no equal, then we use all parentheses. Draw a number line, -14, -4, and +6. So between -4 and +6, less than -14. So this is x less than -14, x between -4 and 6. And that is your answer. Now, there is a what if. What if at the very beginning you have a less than or equal to right here. If you have a less than or equal to, here is how you fix it. This becomes a square bracket. And then the -4 and 6 are square bracket as well. So this is a solid circle, solid circle, solid circle, and then an equal, and equal. If you have less than and equal at the beginning of the problem. Alright, so that is the end of this lesson. I hope you guys are learning effectively from my video. Keep subscribing for more contents. As always, I will meet you all in the next video.